Hello, I'm an old guy and I do maths. Today we're going to have a look at the index rules, or some people call them the index laws. Now there are a few of them, and they're usually numbered, but we won't bother with that. We'll just go through them and have a look at how they work. So starting at the top. First of all, this is an index, and when you have a group of them, they're called indices. Now, this rule says that if this number and this number here, which are called bases, are the same, when you multiply, all you have to do is add these numbers. So 2 to the power of 2 times 2 to the power of 3 is equal to 2 to the power of 5. Now, here's a little example of how that works. So here we've got 2 to the power of 2, 2 times 2, and here we've got 2 to the power of 3, 2 times 2 times 2. Multiply these all together, and you get 2 times 2 times 2 times 2 times 2, which equals 2 to the power of 5. And if you like, you can write this algebraically. Here's the base, here are the indices, and when you multiply the base and the indices, provided the base is the same, this is what you get. You add the indices. Okay, let's have a look at this one. Here we've got a division. And we've got 2 to the power of 5 divided by 2 to the power of 3. So let's go straight to this and you'll be able to see how this all works. So 2 to the power of 5, 2 times 2 times 2 times 2 times 2. I'm glad I didn't write 15 here. And it's divided by 2 times 2 times 2. So what we can do is the following. 2 divided by 2 is 1. So we could put a 1 there, or we could just ignore it. 2 divided by 2 is 1. 2 divided by 2 is 1. So basically we have 1 times 1 times 1 times 2 times 2. Now 1 times 1 times 1 is 1. 1 times 2 is 2 times 2 is 4. So really what we're left with is this, effectively, 2 times 2, 2 to the power of 2. So what you do is you make sure the bases are the same, and if you're dividing, it's going to be 2 to the power of 5 divided by 2 to the power of 3 is equal to 2 to the power of 5 minus 3. Here it is written algebraically. Base, the same. 2 different powers or 2 similar powers, it doesn't really matter. The rule says that you subtract this from that. A is to the power of m minus n, whatever that might be. Okay, moving along. Now, here's one that quite often confuses people. So what's happened here is we've got a bracket in the way. And the question is, why don't we add these? Well, the answer is that the instruction here is fairly straightforward if you think about it. It says that you take 2 to the power of 2 and you multiply it by itself 3 times. So we'll do that. 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2. Now, if you remember the first rule that we looked at, which is up here, where we have something like this, we add the indices. So let's get this back in frame and do just that. So it's going to be 2 plus 2 plus 2, which equals 2 to the power of 6. So how can we short circuit this? Well, you can just remember to multiply these, or you can take an intermediate step and rewrite this as 2 to the power of 2 times 3, which equals 2 to the power of 6. If you want to see it with a letter in here, the same thing happens. A to the power of 2 to the power of 3 is a to the power of 2 times 3. And written completely algebraically, this is what it looks like. Where you have that bracket, you multiply, you do not add. Okay? Right. Let's see what awaits us on the next page. Right. So I'm not really sure how helpful this will be, but it's here for the sake of completeness. Where we have two numbers in a bracket that are multiplying each other, that is the same as writing those numbers with the same power outside the bracket multiplying each other. Does that make sense? It probably makes more sense if you just look at it, but here we go. So what this amounts to is 2 to the power of 2, which is 4, times 3 to the power of 2, which is 9, which equals 36. Now, you can look at this and you can say, well, 2 times 3 is 6, to the power of 2 is 36, and I agree. But it's one of the rules, so we acknowledge it and we work with it. Okay, so algebraically that is a times b to the power of m is equal to a to the power of m times b to the power of m, and you never know, it might prove handy. Now, we have a few more. This is one that sows real confusion. You've got a fraction here, and you have an index here. It doesn't need to be confusing if you just think that what it means is this. It means that it's the top of this fraction, the numerator, and the bottom of this fraction, the denominator, to the power of 3. So 2 to the power of 3 divided by 3 to the power of 3, or over 3 to the power of 3 if you want. 2 to the power of 3 is 8. 3 to the power of 3 is 27. 3 times 3 times 3. So 3 times 3 is 9. Nearly forgot that. 9 times 3 is 27. 2 times 2 is 4. Times 2 is 8. So that is equal to that. Written out algebraically, a over b to the power of m is equal to a to the power of m over b to the power of m. Now, here are a couple of things to remember. Something to the power of 0 equals 1. That's quite handy, and there will be some examples in the playlist involving this, I'm sure. That is, as long as this number here does not equal 0. So anything else, a letter, a number, anything but 0, that number or letter to the power of 0 equals 1. Something to the power of 1 is equal to itself. So 5 to the power of 1 is 5. Obviously 5 to the power of 2 is 5 times 5. 5 to the power of 3, 5 times 5 times 5, and so forth. I hope this was helpful and not too painful an introduction to the index laws. See you next time.